Thank you. So, girls, last week we looked at the different states of matter, and today our lesson will have a continuation of that, basically on evaporation. So we shall be emphasizing more on what evaporation is, how does it occur, and what are some of the daily instances we have about evaporation. Chakra Center, I request for the next slide. So last week we looked at how some of the particles in the liquid state have more energy than others, and this causes some of them to escape in form of gas or vapor, and that is what we call evaporation. But as we know, evaporation, even at room temperature, can take place, and we know that the room temperature is always or usually below the boiling point of a given liquid or the liquid we are looking at. So evaporation, even at room temperature, keeps taking place, though the rate at which it takes place usually differs with increasing temperature or with decreasing temperature. Next chapter. Can we continue? Can we continue? And we know that evaporation occurs at the surface of the liquid. And as I've said, we expect that as temperature increases, the rate of evaporation also does what? Increases. At room temperature, you notice that the rate at which the evaporation won't be as fast as you increase that. So can we have some of the girls give us some experiences they know about evaporation, maybe occurrences where we expect evaporation? Mrs. Kajima, maybe you can help me there.
Vanessa?
Like when boiling water, like when the water starts boiling, of course, like some water has to like escape through evaporation. So when boiling water.
Okay, thank you.
Charity? Charity has gone. Ndagano? Hey, it seems they have the same answers. Okay, our default.
Teacher, when you're drying clothes, the water from the clothes evaporates.
Okay, thank you.
Another hand is still up. Chiravo Eunice?
Teacher, like when you're cooking rice, like when you're making rice, water has to evaporate that the rice gets ready.
Okay, we have Kayesu.
Teacher, when you're drying clothes, water has to evaporate.
Okay.
Thank you.
Rona, thank you. That answer had already mentioned. So girls, put down your hands if your answer has been mentioned. Otherwise, I'll go to Tendo.
Teacher, I wanted to say that in the process of the rain cycle or the water cycle.
Which part of the water cycle are we talking of here?
When the sun rays hit the water, it evaporates into the atmosphere.
Very good, thank you.
I still have a few hands up. Rona, if you don't have something new, put down your hand. Nanyanzi.
Teacher, when you're like cooking spaghetti, the water has to boil.
We need to boil. Okay. The last hand I see up is that of Charity.
Teacher, another circumstance in the rain cycle whereby the trees lose excess water in form of vapor through transpiration into the atmosphere.
Okay, that is good. Thank you, girls, for those answers. And we noticed that in most cases, evaporation is assisted by windy conditions. And depending on some of the examples you've given, I think that is very evident there. And this helps remove water vapor particles from the liquid so that they can escape more. So on the surface of the liquid, as these vapor particles are lost by the windy conditions, you notice that more particles from the liquid will escape in form of vapor. Chairperson, let's kindly have the next slide. So on this slide, you notice some of the few examples that you've mentioned of the daily experiences we have with evaporation. And we notice there is the drying of clothes on a drying line. When you hang a wet cloth, you notice that that water is lost in form of vapor by evaporation, and then drying a puddle of muddy water. Then evaporation may also involve liquids other than water. For example, the perfume. You notice that when someone wears a given perfume, you're able to smell it, and its transmission is by evaporation. Then the air fresheners. So that is why you're able to smell those different aromas or different scents from the source. When you're very far from the source, you're able to perceive that someone has wore a given perfume, or this place has been sprayed with an air freshener, something like that. Then we also notice that evaporation may be of a solvent from a solution. For example, if we have a salt solution where we have water, you notice that the water will evaporate, leaving the salt alone. And as you've given those few examples of the cooking, you notice that most of the water is lost by evaporation, so that you remain with the food substance that you're cooking. Okay, we have some differences between boiling and evaporation. Can we have the girls give us some differences between evaporation and boiling? Some few answers.
Our default.
Teacher, when you're
Sorry. Yes, Crown him.
when you're boiling, let's say water, there are bubbles that form like as it boils. But during evaporation, like if you leave a cup of water outside, no bubbles will form, but the water will just evaporate.
Okay, thank you.
Bravo, Eunice.
During boiling, this is when the particles in the water get possess a lot of kinetic energy, enabling them to move around in the water faster, but not escaping the forces that are holding them. While in boiling, while in evaporation, this is when this is when the water particles gain a lot of kinetic energy and evaporate into the air, like they let go of they break free of the forces that are holding them, enabling them to rise up into the atmosphere.
Okay, let's have someone else.
Rukia?
Teacher, boiling takes place at a fixed boiling point, whereas evaporation may take place at room temperature.
Okay, thank you.
Just a correction, not a fixed boiling point, but a fixed temperature. While the other one is a variety of temperatures. Sechirai. Daniela. Okay, Daniel, we seem to have lost Daniela. Charity. Charity. What's happening? Alema. Vivian.
Evaporation takes place throughout the liquid, while boiling takes place at the surface of the liquid.
Okay.
I have some. If your answer has been said, you can lower your hand. A chain and a peel.
When evaporation takes place, bubbles do not form, while when evaporation takes place, bubbles are not formed, while when boiling, bubbles are formed.
Okay, that was given to you.
Queen Ndagano.
Yeah, evaporation continues as long as the air above the surface of a liquid remains unsaturated. While boiling, it takes place until the internal temperature of the liquid is equal to the external temperature of the surrounding.
Okay, thank you.
I still have the two who failed to talk. Maybe Charity, can you unmute and talk?
I think boiling is when a liquid has enough kinetic energy and heat to change into a gas. Then evaporation is the process when a liquid changes into a gas.
That is all, Teacher Martha.
Okay, thank you, Teacher Eve. Thank you, girls, for your answers. And I think we shall construct more when we move to that slide. Can we kindly find out the similarities between those two processes? Let's have some views from the girls.
Charity Shalom.
Teacher, I think both involve the change of liquid to gas.
Okay.
Okay. Mirembe Emily.
Both involve heat gain.
Okay.
Sorry, I didn't get both involve what?
Heat energy.
Gain, Okay. Heat energy, we need to know, is it heat gain or heat loss? Can someone improve her answer? I didn't get it right. Our default.
She said both involve heat gain, like the process needs heat to occur.
Okay. Okay, they both involve heat gain. Esther, do you have something different?
Yeah, both help in change. Both are processes that help in change of state of matter from liquid to a gas.
Okay.
We seem to be rotating around the same. The last hand up is Chiravo Eunice.
Both are physical changes.
Okay.
Okay, thank you, girls, for answers. Thank you, Teacher Eve. Chairperson, can we kindly have the next slide? So, girls, when you look at the table on your screen, you notice that we've been given the property and then the boiling and evaporation. So you notice the first property is bubbles. And as we've said, in boiling, we notice that bubbles are being formed. I know most of us have tried to boil water at home, so you've seen that. And then in evaporation, you notice that no bubbles are being formed. Then the speed of the process, you notice that in boiling, the process is rapid. And in evaporation, the process is slow. The temperature at which the process occurs, you notice that in boiling, we have a fixed temperature, which is called the boiling point. And then in evaporation, you notice that the temperature fluctuates even at room temperature. As we've seen that in evaporation, we have it occurring even at room temperature. That means it can keep on changing depending on what temperatures the liquid is exposed to. Then we have where the process occurs in the liquid. We notice that in boiling, when boiling, the process takes place throughout the whole liquid, while in evaporation, you notice that it occurs at the surface of the liquid. Then the similarities between boiling and evaporation, we notice that both processes involve the liquid changing from liquid to gas. And then we also expect that in both processes, there is heat gain. And then we notice that they are all physical changes. Okay. If are the breakout rooms ready as Teacher Crescent comes back? Because it looks like we have some questions for the girls to do in the breakout rooms.
Hello, should I do the breakout, rather put the slide for breakout rooms?
Yes, so that they can screenshot the questions.
Okay.
Got that. Girls, let's kindly take a screenshot, or if you're fast enough to copy them down before we go into the breakout rooms.
So how long are we going to be in the breakout room?
It'll take about 8 to 10 minutes.
Okay, I think they've taken the screenshots, so you'll soon find yourself there.
Okay, thank you.
Girls, complete the poll, those who haven't yet. I've lost
Yes,
Teacher Crescent.
As Teacher Crescent comes back, Teacher Eve, can we listen to the girls' questions? I think there is Vanessa and our default.
Okay. Vanessa, ask.
Teacher, I'm just asking, okay, like since like the screen has been removed, I don't remember that question exactly, but she said that she was in a PE lesson and then she sweated and then she sat under a tree and like the sweat like went off. And then on number 2, we have said like it's heat gain that made like that made the evaporation to take place and then the sweat went off. But I don't understand, if she was sitting under a tree, like, okay, where did the heat come from? Like for the sweat to go off from her body?
Good, that's a beautiful question, Vanessa. That is what is being answered in the next question. That's why we said if the process involves heat gain, where does the heat come from? And many of your colleagues said from her body. Her body has heat, and so the sweat gains that heat and evaporates from her body. And we took it further and said that is why she ends up feeling cooler, because her body has lost heat. It has lost it to the sweat which has evaporated. Does that help you at all? Okay, we've lost Vanessa. I'll go to the next question, Laura.
Teacher, I was just requesting if Teacher Martha could repeat the answer for number 4.
Okay, Teacher Martha.
Okay, I said, or if I said, the body feels cooler after sweating. And it feels cooler, reason being, the body will lose its heat to the surrounding. And once there is heat loss, you notice that there is some other source that is gaining this heat. And we've said that the heat that is lost to the surrounding is equal to the heat that is gained by the sweat. Does that answer you?
Yes, it does. Thank you.
No.
Okay, then another one, Ndahura, ask your question.
Teacher, I just want to know if the answer for number 2 was heat gain or heat loss.
It was heat gain.
Okay, thank you.
Okay. Girls, I'm closing the poll. If you haven't voted, please vote. Quickly.
Thank you, Teacher Crescent. We have some, our default, do you still have a question? And Chirabo?
Teacher, doesn't mean who spoke before. I have a question. During cold days, if you do like any physical activity, you start feeling warm.
During cold days, I didn't get the last statement.
If you do any physical activity, teacher, you feel warm.
I don't know if I've heard her right, but she seems to be talking about doing physical activity on a cold day that you feel warm. Actually, when you do physical activity on any day, you should feel warm. Your body now has much heat. As you do exercises, your body generates heat. It makes heat. And that is why you feel warmer. And I want to tell you, even on a cold day, even if you sweat, if you did not wipe that sweat off your body with a hanky and you just sat down, it will eventually evaporate because it's getting heat from your already warm body and using that to evaporate.
Okay, thank you, Teacher Eve.
Chirabo, you need...
Excuse me, teacher.
Yes.
I needed some clarification on this point. When the body generates heat and loses it, the heat isn't involved in the making of the sweat.
No.
Oh, okay.
Actually, God made our bodies that when our bodies heat up and it's detected that our body is hot, one of the ways to cool our bodies is that sweat is produced, so that as the sweat evaporates, the body cools.
Okay, thank you.
Martha, oh, there's still okay, yeah. Martha, you can wind up. We have about 5 minutes. Teacher Crescent's hand is up. I don't know. I think he wants to make a comment.
Sorry, I forgot it up when I was rejoining. So sorry. Let me put it down.
So Martha, I think we can wind up. We have 5 minutes.
Okay, thank you so much, Teacher Eve. So Girls, that was it about evaporation. And thank you for your contributions towards the lesson. You notice that what Teacher Eve was explaining about the sweat. Sweat is as a result of the heat generated by your body. So we notice that when our bodies generate heat, we realize that sweat is the product that is being produced. And unless Teacher Eve and Teacher Crescent have something to add on, I think that's it for today.
Crescent's hand is up again. We can make the, no, we can leave the next slide. Maybe Primrose can ask a question. Primrose?
Excuse me, teacher. I was requesting if you could at least send the recordings of the lessons, of the chemistry lessons onto the Google Classroom, because at times I lose network and I miss out some of the notes and the explanation, and it is making me lack, behind the rest.
Okay, Primrose, thank you for raising that. Whenever we have lessons, the recordings are on the Gayaza High School YouTube channel. Please go to the YouTube channel, you will find the missing lessons. Some might not go there on that day, but eventually they are all uploaded to the YouTube channel. So stop waiting for them in the Google Classroom, okay?
Okay.
Atwine?
Say that the body's heat is one that evaporates the sweat. So like, can it also evaporate like water?
Oh yes. Or now, if you felt hot and put some water on your skin, if you didn't wipe it off, it would also go. And it would leave your body by evaporation and you'll feel cool. Actually, that is one of the reasons we put you find someone pouring water on their body on a hot day because they are feeling hot. And when they pour that water, once the water evaporates, they feel cool. Ndagano, I hope that's the last question.
Excuse me, teacher. Teacher, for me, I've noticed like every time you sweat, then after you cool down, like the body releases like a bad odor. So like, does the sweat evaporate through that bad odor?
No, Queen, if you check the constituents of sweat is not pure water. It's water which has some dissolved salts and other substances. Notably among them, I think there's a substance called urea, which has a smell almost like that of urine. So that could contribute. Some of those substances dissolved in the water to make sweat are the ones responsible for that odor. And therefore, on a serious note, it's therefore important to take a bath when you have sweated. Some of you sweat, then because eventually the sweat goes off in the evening, you're like, but must I bathe? Yes, you must, because your body now has a strange odor which others don't enjoy having. At Kunda, Vanessa, you people with your question. Vanessa?
Teacher, I wanted to ask that since like the body is losing heat like through sweating, shouldn't like the water be maybe like a bit hot? Yet most times it's not hot. So why is that? Shouldn't it be like hot a little bit?
Which water? I'd like to understand you. Which water are you talking of?
Like the sweat on the body, since like the body is losing heat through the sweat. So shouldn't the sweat be like a little hot?
It should gain heat and become hotter than it was. But I don't know if you've carried out a test to determine whether it's hotter or cooler. You'd need a thermometer onto that sweat. Remember, it's a thin layer. So most thermometers cannot detect the temperature of the sweat alone without getting the temperature of the body. But you are right. The sweat before it goes, it must have become warmer than when it first came out. Oh God, Shirabo Eunice.
Excuse me, teacher. Is it possible that when on the previous point we're talking about when like you put water on your body and if you don't wipe it off, it evaporates. Is it possible that the water ends up evaporating because of the sun? If you're standing under the sun, if you're standing in the sun.
Yes, we mentioned the two processes. The body, it can get heat from the body and also from the sun. But we wanted to relate it more to the body because the body is already hot. You get it? Eh?
Yes.
Okay. So both processes can work. And lastly, Vivian, no. Okay.
Excuse me, teacher.
There's one last hand after you. Okay.
So when someone sweats, sometimes also the clothes also get wet. So is it the heat from the body that also makes the clothes dry after when you let the sweat also dry off your body?
Yeah, we'll answer it the same way as the sweat. We've got the heat from the body and people have also added heat from the sun. Yes, the two would work.
Maybe I can add on something that has just come to my mind.
Yes.
If you are using a frying pan set to fry something and it is very, very hot, and then you pour just some little water on it, you notice that the water will evaporate and the pan will eventually get cooled by that heat exchange that has taken place between it and the water. So the pan will cool because of the presence of the water evaporating, because the water has carried away the heat that was in the pan. So similarly, that's how our body also is. Our body is already hot, and in order to cool, the sweat on the body takes away the heat. As it evaporates, the body remains cooler. Thank you.
Thank you, Teacher Christian. Now the very last question from Stacy.
Okay, so I was just asking, if you get a hot cup of tea and that steam that's coming out, it means that it's also evaporating.
Oh, yes. As long as the liquid is turning into gas or vapor and it is not at the boiling point, that is evaporation. That is very true. So girls, thank you very much for being so attentive. Today, let's make a difference. Someone pray for us. We thank God for our lesson. Nakal, okay, some Charity. Okay, Charity, you want to pray? Pray. Charity, your mic is on. Charity seems to be having network issues.
Vessels for prayer lesson. We thank you. I'm praying.
Okay. Oh God, we seem to have lost her. Okay, Namboze.
Almighty God, Father, glory, one.
Oh, wait.